Hey guys, it's Jeremy from the chemistry and I'm super duper excited to be doing my first video in like forever for you guys, okay? Today and the next few videos we're going to be looking at the states of matter, and we know that there are three states of matter that we can find matter existing in. They're solids, liquids, and gases. But before we get started looking at states of matter, we need to just continue off of the particulate theory of matter, which states two tenets. That is, that all matter is made of smaller particles and that those particles are in constant motion. Okay? So today we're going to be looking at the state of matter that we know as solids. So, solids have a fixed volume, they have a fixed shape, they're hard to compress and expand, and the particles inside of the solid are arranged in a fixed manner, and the movement of those particles is that they vibrate constantly. Now, all of these properties that we see on a macro level with solids is the effect of the forces of attraction that are going on at the molecular level inside of a solid. First of all, let's talk about the motion of the particles inside of a solid. Now, as we said, their movement is that they can only vibrate constantly. They're not able to go freely from point A to point B, nothing like that, just vibrate. Why? Because the forces of attraction are so strong that they keep those particles fixed in this one location, and the best that they can do for movement is to vibrate. And that's because the forces of attraction, as we said, are strong. That leads on to the fact that now the particles are always arranged in a fixed manner. Again, that's because the forces of attraction keep molecules close together and packed in tight and close to one another. And therefore, that's why now the particles are arranged in a fixed way. That leads on to the third point. They're hard to compress because you have such a dense region of particles squished together, already tightly packed. When you push it in to compress, you are going to feel those particles pushing back. So that's why solids are hard to compress and likewise hard to expand, because when you try to pull the particles apart from one another, again, the forces of attraction are strong. So they're not going to want to lose their partners that you're pulling away from them. And all of those lead on then to solids having a fixed shape and also a fixed volume, and that's because those forces of attraction do not allow for those molecules to move freely from here to there and increase in volume or change the shape, right? So with solids, as we said in summary, those forces of attraction keep everything nice and locked in.